Hello everyone, I am doing previous year question of thermodynamics from the exams like GATE, IES and civil services. So today I am going to see the question of engineering services. So those who are from mechanical engineering, it will help for you. And the topic will be basic concept. This is about myself. I'm doing for the strength of material, fluid mechanics, material science and other subject as well. So please watch those videos as well. So it will help you. Let's see the question of engineering services from the basic concepts. Okay, so the first question is, not first question, it's the 15th question for the engineering services. In a temperature scale of 100 degrees centigrade, you can say the boiling and freezing point of water degree centigrade. Okay, it's not rho. One temperature is 100 degrees centigrade and 300 degrees centigrade respectively. Correlate this scale with the centigrade scale. The reading of 0 on centigrade scale is like rho. Okay, whatever it is. Okay, so they are asking like this is like it's like I think it should be Kelvin scale. Okay, degree Kelvin. I don't know if they have written rho, whatever it is. Okay, जो भी दिया हुआ, I think it is Kelvin scale. So Kelvin और degree में ही relation होता है. Okay, so obviously this will be Kelvin. So the Kelvin to centigrade we have to write, convert. So okay, see this thing, this figure you see. So we have to write on a 0 degree, 100 degree, 300. So this is Kelvin scale and this is like degree scale. 0, 100 and 0. So what we have to do that, like 0 minus 30, you can see here, 0 minus 30, then 100 minus 30 is equal to, okay, see this one and then see this one. So C minus 0 and then 100 minus 0. You can see this. Just simplify, you will get in degree centigrade. So it is like 150. The answer is D. Next question. In an alcohol and a mercury thermometer, read exactly 0 degree centigrade at ice point and 100 degree centigrade at steam point, and the distance between the 2 points are divided into 100 equal parts in both thermometers. The two thermometers give exactly the same reading at 50 degrees centigrade. A temperature scale are arbitrary. Okay, so this is actually both is correct. Okay, this is correct and this is also correct, but this is not the correct explanation. So that's why the answer is B. Individually both is correct, but it's like the reason is not correct explanation of A. So the answer is B. Next question, we have to match this like thermometer, types of thermometer and thermometric property. So mercury in glass, thermocouple, thermistor, constant volume. Okay, so we have to match with pressure, electrical resistant, volume, induced electric voltage. Okay, so this mercury. Okay, mercury in glass, it will be volume, thermocouple, induced voltage, and thermistor, electrical resistant, and constant volume is pressure. Okay, so the answer is D. Next question. Pressure reaches a value of about absolute 0 at a temperature of minus 27 Kelvin, minus 273 Kelvin, sorry, under vacuum condition at the earth center when molecular momentum of the system becomes 0. So this is actually D, when the molecular momentum of the system becomes 0. Okay. Next question. The time constant of thermocouple is the time taken to attain the final value to heat measured, 50% of value of the initial temperature difference, 63.2% of value of initial temperature difference, 98.8% of value of the initial temperature difference. Okay, it is actually C, 63.2% of the value of initial temperature difference. Okay, so if you want this like time constant, they are talking about time constant. You please read this. Okay, I don't want to read this. Please read this explanation. Okay, but the answer is 63.2% of the volume of initial temperature difference. Next question, okay, work a path function. Okay, assertion, thermodynamic work is path dependent except for the adiabatic process. Okay, it always possible to take a system from a given initial state to the final state by performing adiabatic work only. Okay, thermodynamic work is path dependent except for thermodynamic work is path dependent except for adiabatic process. Yes, this is correct. But it is always possible to take a system from a given initial state to final state by performing adiabatic work. Only, no, only बोल देता तो गलत हो जाता. Okay, so the answer is C. Next question, work transfer between system and the surrounding. Okay, is a path function, is always given by this, is a function of pressure only, depends on path function. Okay, so I think you can answer this question. Answer is will be D, depends on path followed by the system. Next question, free expansion with zero work transfer. Okay, so process characteristics. Okay, throttling process, isentropic process, free expansion, isothermal process. Okay, no work done, no change in entropy, constant in energy, constant enthalpy. Okay, so we have to match with this. I think simple question. Anyway, we'll see that. See, the throttling means constant enthalpy. Okay, isentropic constant. As isentropic process means no change in entropy. Okay, delta S is equal to 0. Free expansion, no work done, and the बचा हुआ हमारा D हो जाएगा isothermal process, constant internal energy. So the answer is A. Okay, so this was the end of like few more questions from the thermodynamics of engineering services question. Okay, I hope you like that. We'll see some more question from the basic concept for the engineering services. Thank you for watching. Bye bye.